So finally, we're going to do one last short video that puts together kind of all of the steps of factoring that we talked about in the last few videos, so that when you get any type of quadratic and you need to factor it, you follow the following steps. First, always factor out a greatest common factor if it's possible. That may not be possible, but you always try to look for a GCF and get rid of that guy first. Then, step 2, look for a special pattern. The easiest and most obvious one to me is if you have that difference of squares. Remember, that's a squared minus b squared. If you have that, you square root the first term, a, you square root the second term, b, and you do one sum and you do one difference. If you have a perfect square trinomial, you'll know it because the first term's a perfect square and the last term's a perfect square, and in the middle you might get a sum of twice ab, and that factors into a plus b quantity squared. Another perfect square trinomial is also a perfect square in the front and a perfect square in the back, but in the middle you have a minus 2ab. So remember, that one factored into a minus b quantity squared. If you don't see any of those special patterns, then just factor by grouping. Okay. Now recall, I'll give you just this hint. If you have just that x squared plus bx plus c, you can use the shortcut. Okay. However, if you have ax squared plus bx plus c, where a does not equal 1, you should group for sure. So maybe we'll see one where we have a shortcut, but I don't know if we have one in this video. In example 1, first thing that I got to do is look for a GCF. Now both of these have a factor of 2 and a u, and that is the greatest common factor. So let's pull out a 2 and a u. If I divide 2u squared by 2u, I'm left with 1u. And if I divide a positive 8u by 2u, I'm left with a positive 4. Now, there is nothing more that I can do with a u plus a 4. That fits no other special pattern. As a matter of fact, it's not even a quadratic anymore. So we're done. In this example, all I could really do is pull out the GCF. So we have factored that problem. Those are kind of nice ones when there's not more to do than that. Here, I have another two-termed expression. Let's see what happens here. First thing, look for a GCF. I know 3x squared has a factor of 3. 48 also contains a factor of 3, so I can pull a 3 out of both terms. If I do, 3x squared divided by 3 leaves an x squared, and negative 48 divided by 3, I believe, is negative 16. If you multiply 3 times negative 16, you'll get negative 48. Now, this opened up a new window, if you will. X squared minus 16 fits my special pattern of a difference of squares. I know that I can square root the first term and get an x. I can square root the 16 and get a 4. So remember, this factors into x plus 4 times an x minus 4. Now don't forget, since we factored out the greatest common factor of 3, I still need to have a 3 out in front. So this problem factors completely into the product of 3 times x plus 4 times x minus 4. Let's do one more example. Let's look at 3 here. I have a 12p squared, a 36p, and a 27. The numbers are not pretty. Those are actually pretty large. I do not want to factor that by grouping. So is there a GCF? I do believe a 3 goes into all of those. So let's pull out a 3. If I pull a 3 out, 12p squared divided by 3 is going to be a 4p squared. 36p divided by 3 is going to be a positive 12p. 27 divided by 3 is a positive 9. Okay, so that's a little bit better. When I look in the parentheses at that trinomial, I'm looking for a special pattern. And I really like the fact that this is a perfect square and this is a perfect square. So I might be trying to compare this now to my difference of squares pattern right here. Let's see what happens. I'm going to rewrite my 3 in front. Now remember how it works is I square root the first term. 4p squared, if I square root it, is just a 2p. And if I square root a 9, I get a 3. Now my middle term is positive, so I should have a plus sign here. Now remember, to complete this, it should be quantity squared. Now, remember how we checked the middle term. I should multiply these guys together. A 2p times a 3 makes 6p, but remember then we doubled it. So 2 times 6p is 12p. Hey, that matches my middle term. So I've factored this one correctly. I have 3 times the quantity 2p plus 3 squared. Thanks for watching.